So in this video, we're going to see exercise. We're going to discuss exercise 8.4, and here we have problem number 1. Let's read what the problem is. Express the trigonometric ratios sin A, sec A, and tan A in terms of cot A. Okay, so we have 6 trigonometric ratios. Let's note them down. We have our standard 6 trigonometric ratios: sin A, then we have cos A, then we have tan A, then we have sec A, then we have cosec A, and then we have cot A. Okay, these are the 6 standard trigonometric ratios that we have. Now the question says that the trigonometric ratios 1, 2 and 3. So let me use a highlighter. Trigonometric ratios sin A and sec A and tan A. These 3 trigonometric ratios should be expressed in terms of cot A. They should be derived, or there should be cot A in their expression. We should be able to write sin A, tan A and sec A in using only one another trigonometric ratio, and that is cot A. Okay, so first of all, very clearly, tan A is reciprocal of cot A. We know that by definition. So let's write that tan A is in fact equal to 1 upon cot of A. Okay, so done. Tan A is done. Now what remains is sin A and sec of A. So let's begin with sec of A. So I'm going to draw a line here. So let's draw a line here. Okay. Now we have to use some trigonometric identities to find the relation between sec A and cot of A. Now we have one trigonometric identity for sec A, and that is 1 plus tan square A, okay, is equal to sec square A. This is the trigonometric identity, which is a relationship between sec A and tan A. However, tan A can be written in terms of cot A. Okay, so I'm going to do that. 1 plus 1 upon cot A, because tan A is 1 upon cot A, the whole divided by square is equal to sec square A. Okay, so that is going to be 1 plus 1 upon cot square A. I'm opening the square bracket. That is equal to sec square A. Now, if you rearrange, this is going to be 1 plus cot. Okay, instead of writing that, I'm going to write. So basically, cot square A into 1 plus 1. Okay, so this is going to be cot square A plus 1, the whole upon cot square A, okay, is equal to sec square A. Okay, thus we can see that sec square A is expressed in terms of the trigonometric ratio cot A. All I have to do is take square root on both the sides of the equation. So let's take square root on both the sides of equation. Okay, I'm just going to write here, take square root on both the sides of equation. Okay, and therefore we are going to get under root of 1 plus cot square A. This is my numerator, the whole upon cot A, because we have cot square A, its square root will be cot A. That is going to be equal to sec of A. Okay, so thus sec of A is expressed in terms of cot A. So I'm going to write this answer here. Let me try to zoom in. Okay, so sec A is now equal to under root of 1 plus cot square A, the whole divided by cot of A. Okay, so let's zoom out. Yes, so this is sec A and this is tan A, both expressed in terms of cot A. Now the third trigonometric ratio is sin A. Now we have to express sin A in terms of this. Now we all know. Now we are going to use another trigonometric identity where we can get sin A in terms of cot A. Let's see how that can be used. Okay, I'm going to go this side rather. Now let me draw a line here. Okay, so we have a trigonometric identity 1 plus 1 plus cot square A is equal to cosec square A. Okay, now note that cosec square A is nothing but 1 upon sine square A. Okay, so that is equal to 1 upon sine square A, and this left hand side remains as it is equal to cot square A, and therefore taking reciprocal on both the sides. What do we get taking reciprocals on both the sides of equation? We get 1 upon 1 plus cot square A as equal to sine square A. Okay, and now that's it. We have to just take square roots. Taking square roots on both the sides. Okay. Taking square roots on both the sides of the equation, we get, so square root of 1 is 1, and this square root is 1 plus cot square A, and this will be equal to sine of A. Thus, sine of A is now expressed in terms of cot A. So, I want to take this value here. It's 1 upon under root of 1 plus cot square A. So, let's again zoom in. So, this is equal to 1 upon under root of 1 plus cot square A. This is under. Okay. So, thus we have successfully expressed these three trigonometric ratios which were highlighted only in terms of cot A. Okay. Now, an interesting property of the trigonometric ratio is that you take any one trigonometric ratio, let's say sine A, and the rest 5 can be expressed in terms of sine A. Okay. So, you take cos A. So, this rest 5 can be expressed in terms of cos A. So, the same thing we are trying to do here. We are trying to express all the other 5 trigonometric ratios in terms of cot A. So, since sin A, tan A, and sec A can be expressed in cot A, even cos A can be expressed in terms of cot A. Okay, because cos A is in fact 1 upon sec A. So, very obviously, and cosec A is 1 upon sin A. So, even that can be expressed in terms of cot A. So, this is an important, let's say, a property of trigonometric ratios, that all the any 5 trigonometric ratios can be expressed in terms of the 6th trigonometric ratio. So, that's what this question is all about.